All right, 2 more to go. Calculus. That was trigonometry. Calculus. Here is our first question. Y equals to 4x cubed minus x to the 4. They commonly love to get you to graph these by first finding stationary points determining nature and then sketching the graph. Here is our first solution. More solution. What have they done? Can you notice? They've gotten rid of the x again. Again, like, so these kind of errors pop up in all sorts of type of questions, not just solving equations, right? It can be in graphing, can be in taking derivatives, right? So they've divided by x here again. It's the same mistake, but in a different context, right? So divided by x here, and they're missing solutions, right? I haven't done the graph completely because obviously they only have one solution here, right? X equals 3, it doesn't really, like, what is that, right? But is anything missing from these? A line, they haven't graphed anything, but also from the axes, right? You need a label, right? So always label axes, right? Very simple kind of thing that can just make your solution less than ideal. So make sure you label your axes, okay? All right, so let's try and improve this solution a little bit. What have I got over here? There we go. So now I've differentiated correctly, and I've even explained my solution bit. I said 4 stat points, right? Just a bit of explanation goes a long way. I did that here as well, though. And I'm solving for 0. I didn't divide. I factorized this time, so it looks good. This is a correct solution, x equals 0 or 3. You guys should have gotten that. And then here's my graph. I've got my axes. What do we think?
Nope.
No? Why?
First off, you didn't define them. Second off, you haven't actually defined them.
I didn't define them?
You didn't define which ways they went.
Good. Okay, so 2 things, right? I don't know if it does say it here. It says determine their nature. Another word for that is classifying. So students forgetting to classify. And that's either using second derivative or table, right? And then also no x or y intercepts. Now, just keep in mind, it may not always be possible to find all the x intercepts. Some questions you can't, right? So in those types of questions, you don't have to do that. So an example of that is this. So x cubed minus 3x plus 2, you can't actually find the x-intercepts in the advanced course. You can use extension 1 methods, but you guys don't need to do that. So that's just an example. You may not always have to find x-intercepts there, right? But in this one, you should be able to, right? Because it's pretty trivial to do that. And then, as James said, they forgot to classify as well. So that has resulted in a graph being not quite right, okay? So let's do this again properly. So we'll take it from this line here. So 4x, let y dash equals 0 for stat points. And so we've got 4x cubed, that's 3 minus x equals to 0, x equals to 0 or x equals to 3. Now when you classify, James, which one did you use? Did you use table or did you table? Yeah, sure, that's fine. A thing with table that you just want to be careful of, make sure that when you're testing the values, 2 things actually. If the 2 stationary points are very close together, make sure you're not testing across over them because otherwise you'll run into issues. That's what sometimes happens. So I always recommend 1 and minus 1 kind of around that point, but sometimes you can run into issues if like the points are too close together. So make sure they're further apart, and make sure also when you put in here, don't just put positive and negative, put the actual value as well, okay? Did you get that, James? Yep. What did you get for that?
So for the 0, 1, I got 16 and 8. So it's
16 and 8. Yep, and then for the other one?
16 and negative 64.
Sorry, mate. 16 and...
Negative 64.
Yep. There you go.
Hey guys.
There you go. Okay, 16 on the right side?
On the
Left side? Negative 24?
Negative 64.
Negative 64, perfect. Okay, so now we know therefore there's a max, max at x equals to 3. What's over here though? Yeah, now here's where you want to be careful with your phrasing. We haven't tested that yet, right? So again, how do we test whether or not this is a quote unquote wobbly one, or I assume you mean something like that, right? Yeah. So you also want to test, you use the second derivative and you check if there's a change in concavity as well, right? Because if it says find the two stationary points, right, you're saying that this is possibly a point of inflection, a horizontal point of inflection. But not only does the gradient have to be the same on each side, you also have to have a change in concavity. So you need to use the second derivative, right? Test for point of inflection. Right, and then you have to use the second derivative to test that as well, okay? So y double dash is equal to 24x minus 12x squared, right? And then if we test these points here, at x equals to 1, that looks like we're going to get 12. And on the left-hand side, minus 36. Anyone test that one, any chance? Minus 36? Yeah. Have you tested it yet? Cool. And you can see that there is a change in concavity, so therefore, change in concavity, therefore, point of inflection. Okay? Say it again. What's the proper word? Sorry? Wobbly wobbly. Yeah, the technical term, right? And then when you're graphing, oh, this is going to be pretty hard freehand. I'll give it a go. Oh, maybe. Should I just upload your picture? Yeah, that's pretty good. Let's use James's one. Thank you, James. How do you look at that? And look at that perfect solution. We've got labels, axes labeled. We've got x and y intercepts labeled. We've got our point of inflection labeled, even with full coordinates, and we've also got our stationary points labeled. So that's looking pretty well good. Sounds good? Yeah. All right. Last but not least, this one. Yes, good old two curves. Two curves get tricky sometimes because there's so many different ways you can go about doing them, right? This scenario here, just have a look at it. We've got two curves over here. We've got y is equal to the square root of x plus 1, y is equal to 5 minus x, right? Here's our first solution. Let me know what you think. Why shouldn't it be minus?
You're finding that area plus that area.
Right, so people look at this and then the first thing that they assume that there's a formula that they've learned that is that they can do f of x minus g of x. They see two curves and they just think like that immediately, right? But this only works when you have two curves where they're one on top of each other. So if I have something like a concave down parabola, and then I have maybe a horizontal line that's going like this, right? And it doesn't matter where it's placed on the Cartesian plane. That kind of confused a lot of people. It doesn't matter if it's above or below, right? If you have this whole curve on top the whole time, you can take that away. You can use the green and the black one, you can take them away from each other, right? But in this situation, we don't have that. We actually have, for this section, like the blue curve is on top, but then it crosses over in the second section. So what that means is you need to actually split it up. When it crosses over at particular points in that same kind of way, you actually need to split up the integral. So you create two areas, right? You create this section and you create this section and then you do them separately, right? So this one here, that's wrong. There's also something else wrong with this notation. Right, dx's here should be in brackets. Again, that's like a little thing that can kind of go a long way, right? Just with the old notation, just like grammar, really, right? Solution 2. So now we've done that correctly. We haven't got brackets there, but I'll put that in. I don't. But it's not wrong, is it? But then the second line, right? What's happening in the second line? So we've added it correctly, and then what have we done?
Sketchy half root.
Does that look familiar to anyone? Right? So we have x to the half plus 1 to the half, and then we have our interesting index. And this is what I'm talking about, guys, right? Because it's not just year 11 and 12 concepts I'm teaching you, right? Even stuff from year 10 is stuff you'll need. If, like, simultaneous equations, index laws, all this stuff here, this is all building up your foundation of knowledge so you can answer these questions. So if you don't know these, right, that is actually stuff you need to work on. It's not just something, it's year 10, don't have to worry about it, okay? Right? And so, yeah, the dodgy index laws have resulted in getting an answer, which isn't quite right. Any solutions I can just copy out just to save you guys some time. So, yeah, let's get a copy of James's one again. Why not? Yeah?
What's the
I don't know if it's right to be fair, but
what's the
That's
name?
how I did it.
What's the name for it? You know when they have the
Yeah, that's alright. So is it okay if I just do
fractions
plus
you
2?
do?
Wait, can I just answer Madeleine's question first? Yeah.
Sorry.
Yeah. What was that, Madeleine?
Is it okay if I just did plus 2 instead of doing the extra?
Plus 2.
Yeah, like I have 2 divided by 2. Yeah, the triangle.
Oh, as in use the triangle formula.
Yeah, is that-
Oh, yeah, that's actually really good. So this is what I'm talking about, like seeing multiple ways of doing things, right? I think it's always cool to find like less complex solutions because once you guys know integration, typically students rely on that. But yeah, if you find that as the area, if you want to use the area formula there, a equals to half times 2 times 2, is it? Yeah, equals to 2, then you can do that as well. Yeah, that's fine. Yeah, really good if anyone did that. How do you like this? Oh, everything's good except one thing, I reckon. Just being pedantic, but writing equals across. But yeah, you probably ran out of space. But if you are going to do that, just do.
it does actually equal this circumstance.
It does, but we don't like to write the equals across. So typically we just do a little column there, just to indicate that you're going over the next part here. Was there a question about this, or was it fine? Yeah, okay, I'll answer in a second. I think that's all I had for you guys today. Huh, great. We smashed it out. That's calculus common mistakes, okay?